Welcome back to quantitative reasoning. Last time we learned that R's summary function gives a 6-number summary of a numeric vector. A box plot displays information that is very similar to the summary function, but as an image instead of a list of numbers. In R, we make a box plot with the boxplot function. We may want to resize the Plots tab to get a nicer view of the box plot. The thick line in the middle is the median. The upper and lower edges of the box are the upper and lower quartiles. Values that are more than 1.5 times the interquartile range away from the box are considered to be outliers and shown as circles. The whiskers that extend from the box show the minimum and maximum of the remaining non-outlier values. We can fine-tune the box plot by adding more arguments inside the parentheses. For example, to give the box a light green color, we add the argument COL for color, an equal sign, and in quotes, light green. Light green is only one out of many colors that R can produce. We can find a complete list of color names that R understands on this web page. We can label the vertical axis of the box plot with the argument ylab for y-axis label equals, and in quotes, something informative such as sepal width in parentheses centimeters. We can give the plot a title, for example, Anderson's iris data, with the argument main equals Anderson's iris data. This command becomes quite long on a single line. So, to make the code more readable, let's insert a few line breaks to stay within the recommended 80-character line length. After you run the command, you'll see the title at the top of the plot. A plot with a single box can be informative, but the real strength of box plots is that you can put multiple boxes next to each other. For example, let's make one box for each of the 3 iris species, that is Setosa, versicolor and virginica, to determine whether they tend to have different sepal widths. Thanks to our expertise in subsetting data frames, we could in principle make 3 different box plots, namely one for each species. But let me show you a trick how we can get all 3 boxes in the same plot. Instead of using iris$sepal.width as our first argument, we're going to tell R that it should split the data by species. We do this by adding a tilde followed by the column by which we want to split the data. In our example, it's the column iris$species. The tilde means as a function of, so we're telling R to view the sepal width as a function of the species. When we run this code, we receive a figure with 3 boxes. From this plot, it's evident that Setosa tends to have the widest sepals and versicolor the narrowest. Multiple box plots are a great way of visualizing data because we can easily compare distributions without overwhelming the viewer with details. There is an alternative to our current argument list for the box plot function. We can remove everything in front of the dollar in the first argument and instead pass another argument to indicate the name of the data frame. Here's what I mean. I erase both occurrences of iris$ in the first argument and add another argument, data equals iris. In our example, both code options are about equally readable, but when the data frame's name is longer than the 4 letters in the words iris, the second option is in my opinion a little bit more readable. R has many more graphics tricks up its sleeve. We'll continue exploring R graphics in our next tutorial. But for right now, let's summarize what we've learned so far. Box plots show minimum, lower quartile, median, upper quartile, and maximum in a single diagram. R makes box plots with the boxplot function. We can show multiple boxes in one plot, split by category, with a tilde notation. Box plots are great when comparing data for different groups, for example species, but sometimes we want to see the distribution for one group in greater detail. In such cases, we visualize data with a histogram. Next time we learn how to make histograms with R. See you soon.